Hi, and welcome back to the course, R for Journalists. In this chapter, we are going to get into data visualizations by making charts with ggplot 2. So we are going to open up the folder, and this folder is called Charts with ggplot 2. You can open up the RMD file here, or for me, I'm going to open up an R script and make sure my session is in this particular section of the chapter. So let's load some data to create a chart and break down the layers, and I'll explain to you how ggplot applies to it. So we'll start with data from Vulture comparing ages of leading men in movies compared to their love interests. So we will start out with the library reader, and the command to bring in data, we just want ages. So let's call it ages, and that can be found in the after the read CSV function, and that's in the data folder for me, ages.csv. You can also start running it through the chunks if that's how you want to follow along, or you can be like me and type it out. So there it is in our global environment. Let's take a look at the first 6 rows. So we got movie, genre, actor, age of the actor, actress, actress age, and the budget in millions. So this is pretty tidy data. So let's run the code that I've got in the website. I'll explain to you what it is. So first set of the first command is loading in the library ggplot 2. If you don't have it installed yet, then do the install.packages parentheses in quotation marks ggplot 2. And let's run this set of code, and I'll break it down what's happening. Okay. We have a scatter plot. And what does this chart show? It shows that men tend to be much older than women in movies, because this should be 1-to-1, and I guess ideally it would be like 1-to-1, a 40-year-old actor, 40-year-old actress. But that doesn't really reflect the reality of it. So this chart is, you start out with the data, and so in this line right here, we start out with the data frame, which was ages. So we initialized this data viz function, ggplot2, by passing the ages data frame to it. Alright, so you see it highlighted up there. And then then we move on to the next section, g_point, and that is represented in the chart as the dots on the plot representing the relationship between the x and the y. So, and you see it in the line, the mapping, and in here mapping, that describes how the aesthetics should relate to the variables in the data. The aesthetics are x, which was the actor age, and y, which was the actress age. So the aesthetics are the visual characteristics that represent your data. Just so think about this for all charts, all visualizations. The aesthetics are the characteristics, and there's other types of aesthetics you can use. So the default geometric object is what we put in here, but there's other stuff that's customizable, such as position, size, color, shape, transparency, and fill. So think about all those dots. They could be different colors, transparent, etc. So for each aesthetic, we can set the scales for how each visual characteristic is converted to display values. So we'll practice this later on. But let's take a look at the geom label here. And just to kind of break it down even more, what's going on. So you start out with geom_point, which is the type of layer. And you've got the aesthetics, which is represented by AES, and then you pass it the X variable, which is actor age, like I said, and Y variable, which is the actor's age. So you'll notice also that ggplot requires a plus between functions, whereas before, with wrangling data, they used pipes. So the thing is, this package was created by Hadley Wickham before he created, he finalized working on dplyr. So it's a weird quirk that I find myself messing up often, since the shortcut for piping is pretty much muscle memory to me. But if you're using ggplot, just remember to plus it, and for everything else, pipe it. So, breaking down the basics of this function again. So it's ggplot, data equals, and then you pass it the data frame, data, and then geom function. So there could be more than one. There's more than just point. Okay, there's geom other stuff, which we'll get into, like geom bar, geom box plot. So no matter the geom function you end up with, it still requires mappings to be passed to it. Okay, so in this instance, it's those things. So this is basically, these are the only two lines you really need to make a chart in R. You've got the data, and you've got how you want it to be visualized, and what should be visualized. Okay, but we can add more instructions for clarity. So the scaling in this chart, in the output of this original chart, is linear, right? But it's set to start at 0 axis and end at the 60 on both ends. Well, 60 on the y-axis and 65 on the x-axis. And we did this because we wanted to show the scaling to be more accurate, because otherwise it would fit all the dots onto a plot, and then it would be 20 to 65 and then 20 to 60. Well, is that even 20? Yeah, it kind of, it's harder to see the disparity. It was more obvious the other way, because it shifted. So we wanted to emphasize it by starting it at 0. Plus, there's a large contingent of data visualization pros that might yell at you for not starting the base at 0, even though there might be some exceptions to that rule. So the next line that we visualized, selecting and running everything up before that plus sign. I can now run that last one. That's the last line that we're talking about, which was the line representing the 1-to-1 ratio. All right, and that was the function geom AB line. So each function in ggplot2, like geom AB line, allows for additional variables that can be passed to it. In this example, we specified that the intercept should be at 1, but what if I did it at 2? Okay, you'd see it increases more. The last thing I want to talk about is that the coordinate system is Cartesian, and that's just a little bit of sense for like maybe logarithmic and stuff. It's you won't really need to wrap your hand around it yet. It's more like, this will make sense later on when you're dealing with maps, which you can do with ggplot2, and we will get to that in the next chapter. So let's make some charts. But first, you have to really consider the structure of the data when you're working with ggplot2. So we have 6 variables, and each row represents a single movie. And it seems like an obvious data format, but not all data sets have this structure by default. Recall that the previous chapter we were dealing with wide data versus long data. So it's better for data to be long like this, for the most part. So geoms. Let's go over different geom types with this ages data frame. So let's create a simple bar plot. That's the most common. So we'll start with ggplot2. and data is ages, and then I'll do the comma, AES, X equals actor, and then outside of that parenthesis, plus geom underscore bar. So run that. Okay, so there's only one variable we passed to it, which was actor. And in this instance, it just counted up the number of times actor showed up in this data set. And that's what the distribution is. So Denzel shows up 10, Johnny Depp is about... No, sorry, everyone else was 11, Johnny was 10. So it was between 11 and 10 times in this data set. So we started out with one variable, and we're going to keep track of all the variables that we use in these visualizations because that's important to know later on, just how to keep track of them and what they're capable of. So let's talk about other options that you can pass to it. You can pass width, you can pass fill to geom bar, you can pass color, and you can pass position. And so what I mean with some of these things you can fill, let's talk about stacked bar plots this time. So it's the exact same thing as the regular bar chart, ages, and this time AES, we have X equals actor, comma, and this time we're going to fill with the variable genre and give it geom bar. So now we're increasing one variable into two being visualized. And it looks like that. So what just happened? The only difference between the bar plot and the stacked bar plot was that fill equals genre line here. It was added to the AES parenthesis. So it automatically detected the variables within genre and grouped them up. And you can see it's grouped up by factors, so alphabetical. So these are some of the things. Like I said, you can pass position, size, color, shape, transparency, and fill. So looking at the formula again, you've got the things important are the aesthetic properties and the variable to map those properties to. So what if we changed the AES from fill to color? So color instead of fill, plus geom bar. Okay, so that's not as effective as a visualization, but you know what the options are for color now. So when is using color a good option? For line charts or dots, when there's stuff that isn't really being filled. So you notice how the legend and the color was added automatically. So you've got the visual space, and these are the default palette of colors. You know, red, brown, green, aqua, blue, and pink. And it divided it up amongst all the variables that were there, and it assigned it in that order that it always comes in. So this is the default color list, and there are ways to customize the colors that you're going to use, but we'll go over that in the next section. So let's go back to fill equals genre, but this time with a twist. So I'm going to type it out because I want to show you what happens if I do something like ages, AES, X equals actor. And this I'm going to put the parenthesis here, and then fill equals genre. So plus geom bar. So it's pretty much this code up here, but the difference is the parenthesis is no longer outside, but it ends right here. So what happens when I do that? So what happened? It's closed off before the end of the aesthetics, so the mapping for this particular variable was not recognized. So now it works. So sometimes when you're working with ggplot and you're coding and something will not exactly look the way it should, you think it should, it's probably because you've misplaced a parenthesis in that line. You'll get used to it eventually, or you really kind of won't, like me, and you just have to just munge your way through it and figure it out. Okay, so let's talk about the next kind of bar plot, which is a grouped bar plot, and that's ggplot, and then data equals ages, comma AES, x equals actor again. We're going to stick with the fill, and then plus that, geom bar, and this time we're going to pass an argument to it, which is position. Alright, so you can see this looks more familiar, I believe, to what you're used to. At least there's plus and minuses, like I talked about in the previous video, of visualizing data this way. This one you can kind of very easily compare things now. Like you see Denzel is in a lot of dramas, Richard Gere's in a lot of romance compared to everyone else. Okay, so this is nice to look at, except the widths are kind of off. So there's another command you can do, which is in the new version of ggplot 2, and I think this will work. Jog 2. Fingers crossed. Okay, that didn't work. Oh, okay. Well, the new version, when you pass it a second dodge, it will preserve the widths of every single one, which will look better. And so you kind of saw me do this other thing. So the last thing we're going to do is percent bar chart. Using the same set of variables. It's just, we're trying out different methods of visualizing it. So we're going to keep things the same. X equals actor. Fill, still genre. And in geom bar this time, we're going to try position. This is equals fill. That's the argument we're going to send. And now we see things broken down between 0 and 1, so that means 100%. So you see large percent are dramas, and then you can see, oh, well, Johnny Depp, a lot of dramas, fantasy, and so you kind of see the breakdown that way, and it allows for greater understanding of proportion compared to other actors. So, okay, we've gone through a lot of things in ggplot 2. We went over all the different types of layers: data, mapping, aesthetics, scales, annotation, well, not annotations, and types of bar plots using just the same set of variables. Next, we're going to go over more charts using ggplot 2. So, I'll see you in the next video.